Hello everyone. Today I'm going to show how you can use ChatGPT for benchmarking. As you can see here in the past, I used the GPT-4 Turbo, GPT4o, and the GPT 3.5 Turbo 0125 models, and I fine-tuned this version for brain MRI analysis. As you can see here, there is some results, all tests completed, and the best model is GPT 3.5 fine-tuned. Like my fine-tuned version is good at predicting medical analysis than the GPT4o or GPT4 Turbo. How actually benchmark this? Now I will show this. I'm making this open source. You can search for this in the GitHub. Just go to GitHub repositories and here AI model API. Here you can see benchmarking. Here all of the tests, everything, and here you can see the actual API. Let's move on. And the benchmarking, here you can see the three main files for three main models like GPT-4 Turbo and GPT-4o, my fine-tuned model. Here, this is the validation. This observations model have not seen. Here, brain MRI data 2023 full.csv. You can see all the observations. Here should be around 200, more than 200 observations. Formatted version and the JSON-L. For fine-tuning, you should upload the JSON-L file. Here you can see I fine-tuned the model. Here the loss, validation, some metrics, API. Okay, let's back to benchmarking. Write some functions for separate models. For example, GPT-4 to import some libraries, load the env and called OpenAI, passing the API key. Here you can see example. You can copy like this. Open your terminal, cp and .env example to .env, and you are good to go. Okay, replace with your API key here, and here this is a function that gets the text, observation text, and return the response text. It's plain text. Here you can see input, output. It's like a few shot prompting, and finally you pass the text. Also modify parameters, or you can leave as it is. Here we got the response. It will return the plain text. This is the same for GPT4o. You just replace the model GPT4o, and this is also same for fine-tuned version. You just pass your fine-tuned model. You can get this here after fine-tuning. And now the most interesting parts, benchmarking itself. I evaluate, as you can see here, I evaluated using GPT4o. As you can see here, we have a bunch of functions. Now let's start from one by one. Here the starting point, if name equals to main, and we paste the JSON-L file for validation. Models that I will use for benchmarking. I will compare the results like GPT-4 Turbo, GPT-4o, and the GPT 3.5 fine-tuned for medical analysis. And this is on the try-catch block for M. In the models, for each model, I will look and print text processing model, and the processing with I pass the model and JSON file pass my validation. And then let's go to processing. Here you can see we get the model. I create a new JSON file for this model. So I could save the analysis. For example, first observation and the real conclusion. You can see generated conclusion and evaluation. Grade 0 from 100. And the second observation, you can see real conclusion and the generated conclusion. Evaluation, grade 20 from 100. This generated conclusion is generated by GPT-4o model. Grading is evaluated by GPT-4o itself also. And this is the same for all the models. As you can see in the test, every time in the processing, every time here, I loop through the models and I will process. Every time I will create new JSON file for saving the results. And you can see evaluation is 30 from 100. It means GPT-4 Turbo was better in the first observation than the GPT-4o. and the first observation. And this is the same for fine-tuned model. You can see first observation, real conclusion, and the generated conclusion by this fine-tuned model on the real medical data analysis. And you can see grade 90 from 100. This means it's pretty well. I create a new content string, this data that I will pass to the model for evaluation. And here you can see observation list and the real result list that I will get from the JSON-L file. Here you can see another function, get observation conclusion, was passing JSON-L file pass. It's here. We get the file, we create new list, observation, and the conclusion list. Like for real observation and the real conclusion, we open the file with the reading, and for each line, because our JSON-L is separated by line, and then I will just save each observation and each conclusion in the list, and I will return them here. After I get the results, I create a new list for generated conclusion, and there is a length of observation list. It should be 11, and for each observation, I look and get the conclusion for each model. For example, if here we got the model name, and I'm checking if the current model is GPT-4 Turbo, you should get the conclusion from GPT-4 Turbo. If GPT4o, we should send the request for GPT4o. If it's fine-tuned version, you should send the request to fine-tuned version of model. You can also make it one, like you can here pass also model name, for example, model, and the replace just. We can do this also. As you can see here, we get the conclusion and we append to list our generated conclusions. And for each observation, I mean the total observations, I will loop and make a, like here you can see, I will send this file to GPT4o for evaluation. You can see test 1, a real conclusion and generated conclusion. List them here and print testing model. Testing started and the content string, we print the content string. I'm backing up, I back up the, as you can see here, this string. I back up because there is a chance that after sending this generated conclusions and real conclusions to the model, and the evaluation could be error. In this case, you should again generate here, again and again generate the conclusions. So I faced this problem and back up in the separate txt file. Here, just open the txt file with the model name and just write all the content. As you can see here, 11 observations. Okay, print backup content here and some file. And here I'm trying to evaluate the real observation with the versus the generated observation again and again. You can see it's under a while block. There is success, false, and the while not success, try, and accept. Because before this, I also faced an issue while I passed the content. There was model return the grade list not as I expected. For example, I expected integers. Sometimes it's returned with here is a string. Here I call the test model with passing the content string. To get the results, here is the test model. As I mentioned it earlier, I evaluated with GPT4o, the most advanced model. Here is the instructions. You will be given the two medical conclusions. Your task is to evaluate the quality of the generated conclusion versus real conclusion from 0 to 100. You must return the evaluation in the following list format. And here's the list. of integers. Never return the explanation or comments. Return only list of integers. You will be given a real conclusion and generated conclusion in the following pattern. And here's the pattern. Test with number. Here will be observation, like we have 11 observations, like test 1, test 2, test 3, and real. Here will be given a real conclusion, and the generated conclusion goes here. And this is a simple instructions, and I paste the content itself. I mean the real and generated ones. And then I got the response text. It should be list. Here I'm checking if not response text, rise error, and the try catch JSON loads response text, get the grade list, and the accept failed to decode JSON from the response text, and just return the grade list. Here I get the grade list, and I go here, just print grade list and the terminal, and starting the benchmarking. Like try benchmark JSON file pass, observation list, real result list, and generated conclusion list with grade list. Let's see the benchmarking here. I'm saving this for analysis. You can see, as I showed earlier, JSON here. It will save like this. Data, and this is empty. Here you can see list. It will be empty. And the first, and then I will loop through each observation and append. I can say it's a JSON, you can say the dictionary, it doesn't matter. Observation, real conclusion, generated conclusion, and the evaluation with the grade and from 100. Also, there is average grade. It will sum up all the grade list and divide length of grades. And I will append at the end. And I will write in the separate file, JSON file. As you can see here, this is average grade, 52.7272. Okay, and then we write the benchmark into JSON file, and then we just print the model completed, and then waiting for 60 seconds before processing the next model. You can omit this, it doesn't matter. And the sleep. After looping each the model, GPT-4 Turbo, GPT4o, and the fine-tuned version, we print all tests completed successfully and the best model. We get the best model from the average. Here you can see the function for getting the best model. We pass the model list, and for each model, we search from the JSON files. For GPT-4o is average 52. For GPT-4 Turbo, it's 50. And then fine-tuned version, it's 58. We get this average grades here. And then we compare and return the model name. Here we get the model, and the best model is model name. And that's it. That's just a bunch of functions, and we evaluate the results, like compare the results using the GPT-4o evaluation.